Santham Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Good morning, students. Today we are going to study about the refraction of light through prism. In case of the prism, the incident light can be of two types. In the first diagram, this diagram, the incident ray is representing a light of a single color, and this light is also called as monochromatic light, where the mono word it means single and chromatic it is a word which is related to light. So the first diagram is representing the refraction of the monochromatic light through the prism. The second case is that in which the incident light it is the white light. So now let us discuss about the refraction of both the types of the lights one by one. In this figure ABC, this is the triangle which is representing the prism, where AB and AC, these are the two refracting surfaces which are not parallel to each other. The angle A, where these two refracting surfaces are meeting, this angle A is called as the angle of prism. In case of equilateral triangle prism, this value of angle A is equal to 60 degree. BC is called as the base of the prism. This is the incident ray which incidents on the first refracting surface, that is AB. The point at which the incident ray is touching the refracting surface AB, there we have drawn a normal, and that is named as N1. In this case, since the ray or the light is travelling from the rarer to the denser medium, so according to the rule of the refraction, the refracted ray will bend towards the normal. Now in this diagram, this is termed as, or this ray is termed as the refracted ray. This refracted ray is incidenting on the second refracting surface, that is AC. That means the refracted ray is acting as an incident ray for the second refracting surface AC. In this case, the ray will travel from the denser to the rarer medium. So on this refracting surface AC, where this refracted ray acting as an incident ray is touching this side AC, there we are dropping a normal, and let us name this normal to be N2. Because of the propagation from denser to rarer medium, the light ray will bend away from the normal. This light ray, which is obtained back in the same medium, is called as an emergent ray. So in this diagram, we have talked about the three rays. The first one is incident ray, the second is the refracted ray, and the third one is the emergent ray. Now here, the angle which is formed between the incident ray with the normal is represented by I and is called as the angle of incidence. When we are talking about the angle which the emergent ray is forming with the normal, it is labeled as E and is called as the angle of emergence. In this case, the refracting surfaces AB and AC, since they are not parallel to each other, so the incident ray and the emergent ray, they are also not parallel to each other. Coming to the next angles, since here it is a refracted ray, as we can see in the figure, this refracted ray is forming the angle with both the normals N1 and N2. So here we are labeling the two different angles of refraction and we are naming it as angle R1 and angle R2. One more angle is to be defined in this figure. Now in order to get the definition of that angle, to which we are calling as the angle of deviation. For this case, we have extended back the emergent ray and we have extended the incident ray, which you can see easily in the diagram that these extensions of these rays are shown with the yellow color. So, when I am extending the emergent ray in the backward direction and I am extending the emergent ray this way. So, there is an angle formed between the extended incident ray and extended emergent ray. This angle is called as the angle of deviation and is represented as capital D. So, this is the diagrammatic representation to understand the refraction of the monochromatic light through a glass prism. Let us now understand that what will happen when the white light will be incidenting on the first refracting surface of the prism. Now, this is the white light. In this case, when the white light, which we are knowing that it is the combination of the 7 colors, when it incidents on the first refracting surface of the prism, it is splitted up into the 7 colors. These 7 colors are emerging out of the second refracting surface and these colors are in the sequence of Vibgyor. Vibgyor, here it means V, it stands for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange and R for red. So in the diagram, we can see that violet color is the color which bends the most in this case and the red color is that color which bends the least when we are getting these colors out of the second refracting surface. So here this process in which the white light is splitting up into the 7 components or 7 colors is called as dispersion. So, the definition of dispersion can be given as the splitting of white light into 7 colors. This process is called as dispersion and the bend of these 7 colors in the sequence Vibgyor, which is obtained, the name which is given to this bend is called as spectrum. So here we have understood that when the refraction of white light will be taking place through the prism, the white light will be splitting up into the 7 components or 7 colors. The name of that phenomena is dispersion and the bend of these 7 colors is called as spectrum. Let us study about the recombination of spectrum of white light. We know that the white light splits up into the 7 colors in the process of dispersion. Now here, this is a prism, first prism, which is labeled as A, B, C. The white light is incidenting on the refracting surface AB and is splitted up into the 7 colors ranging from V to R, that is from violet to red. Now another prism is being taken and is kept in the inverted position, and the VIBGYOR, the 7 colors which are obtained in the process of dispersion, all these 7 colors, here I am writing the colors as well. So all these 7 colors are now incidenting on the refracting surface XY of the second prism. These are getting refracted inside the prism, and as you can see in the diagram, the final color which is obtained in the form of emergent light is white light. So students, we have started with the white light which was incidenting on the first refracting surface of the first prism, and the final output is obtained again in the form of white light, but it is obtained through the second refracting surface of second prism. So this is said to be the obtaining the process. So this process of obtaining back the white light with the help of 2 prisms when the second prism is kept in the inverted position is called as the recombination of spectrum of white light. From this experiment, Newton concluded that the sunlight is composed of the 7 colors, that is violet, indigo, blue, green, yellow, orange and red. Let us now know about the rainbow formation. Rainbow is the application of dispersion phenomena in nature. First of all, we have to understand that what are the atmospheric conditions for the observation of rainbow. So rainbow is always seen when the sun appears in the sky after a rain shower, that is just after the rainfall. If the sun appears in the sky, at that time there are chances to see the rainbow in the sky. And the second condition is that the position of sun is behind us. Now, what role is being played by the sun and the rain shower? So just after the rain shower, when the sun appears in the sky, at that time the water droplets are suspended there in the atmosphere. Now these suspended water droplets, which is shown here, one of the water droplet in the form of a sphere. So all these water droplets, they act as prism. Then here this is the light ray which is coming from the sun, or I can say this is the sunlight or the white light. When this white light enters in this water droplet, according to the phenomena of dispersion, the white light or the sunlight is splitted up into the 7 colors. From the another refracting surface, all these 7 colors are reflected internally, means within the drop or inside the drop from the second refracting surface, the colors are reflected back. And afterwards, from this surface, these colors, all the 7 colors, they are obtained and seen in the sky in the form of rainbow. These 7 colors are obtained outside this water droplet and are seen in the form of the rainbow. The sequence of the colors in this rainbow, which we are able to see in the sky, is ranging from violet to red, means in the form of the sequence Vibgyor. So, between violet to red, the colors are seen in the sequence of, just after the violet we can see the indigo, then blue, then green, yellow, orange, and then it is red. So this way the 7 colors are seen in the atmosphere in the formation of rainbow. Now these are the 3 phenomena which are responsible or which are taking place at the time of rainbow formation. These 3 phenomena are, the first one is refraction of the light. When the sunlight it enters inside the water droplet, the medium is changing, so the phenomena which is taking place there is refraction. The second is the sunlight is splitted up into the 7 colors, so second phenomena is dispersion. And the third one, from this refracting surface the colors are reflected inside the drop or within the drop, so that phenomena is internal reflection. Let us know about what is the meaning of the term atmospheric refraction. Students, all of you are aware of the term refraction, that it is the phenomena of bending of light ray when it goes from or it travels from one medium to another medium. Now with refraction, when one more word is added, that is atmospheric refraction. So let us see what does that mean. So atmospheric refraction is the phenomena of bending of light rays due to the different densities of air in atmosphere. We know that from the ground to the certain height, the height up to which the atmosphere exists, we know that the density of air in all the layers or at all the heights is not equal. So, from any of the object from the top, if the light ray starts traveling and it enters in the atmosphere, so certainly it has to cross the different layers of air, and all these different layers of air have the different densities. Now when these layers have the different densities, so all these layers are acting as the different mediums for the propagation of light. And through these layers of air, when the light propagates, that phenomena which takes place there is called as the atmospheric refraction. Now let us study about the 2 applications. Out of that, the first one is the twinkling of stars. During night, all of us have observed a number of stars which are twinkling high up in the sky. Today, let us know about the reason for the same. Now here this is the ray diagram in which S, it is the point which is representing the position of a star. These layers which are drawn with the dotted line are representing the different layers of air. The incident ray, which when drawn from the star, it travels through the different densities of air, and since here its propagation is taking place from the rarer to the denser medium. How did I say that? Because we know that the density of the air is more near the ground, and this density of air, it keeps on decreasing as we go on the height. So when the light ray is coming from the star, continuously it is entering in the denser mediums. So, every time according to the rule of the refraction, that light ray from the star bends towards the normal. Finally, when the refracted ray is reaching to the eyes of the observer and is extended in the backward or in the upward direction, here I will be getting a position of the star to be S dash, which is obtained at a point which is slightly higher than the actual position of the star. So here in this diagram, S it is the actual position of the star, but what we all are seeing the stars in the sky during night, all those positions of the stars are not their actual positions. So, what is the name given to that position which is not actual? That position of the star which is marked as S dash in the figure is called as the apparent position. Now, since the atmospheric conditions do not remain same always, means the density of air in the different layers, it keeps on changing. That is why whenever we get the light coming from the star into our eyes, which is crossing the different densities of the air, the stars appear to us twinkling in the sky. Coming to the second application of atmospheric refraction, that is advanced sunrise and delayed sunset. It means that the sun, it appears to us in the sky 2 minutes before the actual sunrise, and it is also seen in the sky 2 minutes after the actual sunset. At the time of the sunrise, if in this ray diagram we are taking the condition for the position of the sun towards east direction, so certainly this diagram will be helping us out to understand the case at the time of sunrise. Now, here in this diagram, S is showing us the position of the sun which is below the horizon. Now, the light ray which is drawn from the sun, it reaches to the earth after crossing the different layers of air with the different densities. Now, when this refracted ray reaches to the earth and is extended back, so here the position of the sun which is marked in the figure, it is S dash, which is representing the apparent position of the sun. So, actually the sun takes the time of 2 minutes to reach from this position to this position, or in other words we can say that when actually the sun is present at this position, we are able to see the sun in the sky at position S dash, which is its apparent position, and the time difference between these two positions is 2 minutes. The same phenomena takes place during evening at the time of sunset, means the sun, it goes below the horizon, but after that also for 2 more minutes we are able to see the sun in the sky. So, I hope students, all of you have understood these different topics which we have studied in this video. Thank you all for watching the video.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.